Hey everyone, welcome back to my channel EduVibe. As you know, earlier we started the atomic physics in the previous lesson. Now today we are doing the next topic of this unit, which is the discovery of the nucleus. Basically, we do today the Rutherford model of the atom. So we done the discovery of atom in the previous lesson, which is done by the Thomas model of the atom. And the drawback is that they said that uh, that atom is made of the distinct positive and negative charges. But that's the drawback which can be done by the Rutherford model, and Rutherford model can be discover the nucleus too. And this whole thing done by the Rutherford model. So let's start with the experiment which they done. So the experiment they done is the gold foil experiment. So you can see over there, this is the experiment they do. So this is a gold foil over there. So what they do, the Rutherford has the two of his assistants look at the spreading of the alpha particles when they struck the gold foil. So they have some alpha particles and they target those alpha particles onto a gold foil, and the observation can lead to the discovery of the nucleus. The Thomas model of the atom predicted that the gold atoms were of uniform density, and as a result, alpha particles should not scattered when passing through the foil, they should pass the straight through. They discovered that, according to the Thomas experiment, the alpha particles should not scatter. They pass in straight to the foil and they pass straight through the backside of the foil. Inside the lead box, which had the small opening, a few milligrams of radium were placed there, and the radium emitted a pencil-shaped beam of alpha particles which were directed at the gold foil sheet and directly pointed to the beam of the alpha particles. They had the beam of particles and they get ready there like that type of thing, that type of all the experiment all the particles they turn and let the target the gold foil in that. What was expected according to Thomas model of the atom was that the alpha particles would pass through the gold foil with no deflection. According to Thomas model of the atom, the gold foil says that in this thing that Thomas says that alpha particles will go straight to a gold foil without any deflection. But this did not happen. This happen in that thing. What will happen? So the most of the alpha particles travel through the foil with a deflection of the angle of 1 degree or the less. As the scattering angle increases, the number of alpha particles directed dropped off drastically. A few alpha particles were directed with the large striking angles, which were about 140 degrees, and some were even deflected straight backwards. What turned in this? So when they put the gold foil atom on the any atom, they will see that sometimes some of the alpha particles go straight, some particles put with a small angle like this, going with a small angle of 1 degree, they deflect it, and some are going with 140 degree angle, some even return backwards. That which is not expected by the Thomas model, but with that experiment, that model can be not be very good in that case. So eventually Rutherford figured out the answer. Here our hypothesis with the positive charge of the gold atom must be concentrated with a tiny volume, such that the most of the gold foil was empty space. This would explain why so many of particles were barely deflected, and after some that underwent large deflection. So what they Rutherford can figure out the answer that some of the space in the atom can just be empty, but there is something at the center of the atom which is a result of the deflection, which that is the thing which doing some deflection, and there's something which is empty, as they said. Rutherford showed that the positive charge and the most of the mass of atom are contained in the radius of the less than 10 to minus 14 meters. There's some of the space which is at the radius of that. Rutherford and all the assistants had discovered something called the nucleus. Discover the nucleus from here, that at the center of the atom there is the nucleus present, which is the name the nucleus, and that nucleus can do that diffraction. So Rutherford work disproved the Thomas model of the atom at that point. So what they do after that? They will turn that theory and they will say that how this will happen, all the things. So Rutherford discovery of the nucleus quickly lead to the Rutherford model of the atom. So this will become the Rutherford model of the atom because they do something and they discover the nucleus from that, and they disapprove the Thomas model of the atom at that time. In this model, the electrons orbit the nucleus. They also mention that electrons are orbit the nucleus. They don't like inside anything. They don't like inside the atom. They are orbit the nucleus. So over there they answer that they orbit the nucleus, similar how the planets orbit the sun. The centripetal force that keeps the electrons in their orbit is provided by the electric field. Electric field attraction between negatively charged electrons orbiting the positively charged nucleus, which is assumed by the model of the Coulomb's law. From the Coulomb's law, they are proceeded also that the centripetal force can be occurring in the electrons. They provided the electric field between the negatively charged electrons and the positively charged nucleus. So the positive charge is on nucleus, the negative charge is on electrons, and electrons are orbit their nucleus in that case, like this. So these all on that orbit, they have electrons, and that at center we have a positively charged nucleus in that at the center of the atom. So that's the model of the Rutherford, and that model you have to know. All the model you have to know, but this is like a model which discover the nucleus. The previous model which have the electron, which is good, but there are some drawbacks which is done by the now, which is like approved by the Thomas model. At the end, they do some like explanation of the results. So the model will explain the results of Stratin experiment quite well. So most alpha particles went with the no deflection because the atoms are mostly empty space. That's why the most alpha particles move through into the no interaction with the gold atoms. The few alpha particles traveled at the significant angles, significant like 41 degree, 1 degree. The ones that get close to a nucleus are deflected by the electric repulsion. The atom which is go by like a very closest to a nucleus, they will do the electric repulsion because the alpha particle has a negative charge, positive charge, and that thing also a positive charge, so they do a repulsion in that case because the nucleus is also positive. That's why they say that nucleus is positive, and the nucleus and particle both are positively charged. The closer the particle called the nucleus, the greater deflection can be occur as per the Coulomb's law. They also mention that all can be done by that all thing is done because of the Coulomb's law. Because Coulomb's law that how if the closer the particles go to the nucleus, the greater the deflection can be occur because of the Coulomb's law again. From this too, the Coulomb's law can be like re-revised, and Coulomb's law can be again coming that thing with the Rutherford model of the atom. To calculate the size of the nucleus, Rutherford replied that the law of conservation of energy and an equation of the electric potential energy. The equation of the electric potential energy that can get charge of Q1 gains from the electrode around charge Q2 is given by this. So EP, which is the electric potential energy in joules, is equal to K times Q1 Q2 upon R. R is the distance between the charges in meters. Q1 and Q2 are the magnitudes of the charges in coulombs, and K is the Coulomb's constant, is 8.9 into 10⁹ Newton meter square per Coulomb square. So that's the formula which is equal to electric potential energy. That formula again you turn in forces and fields, but now you involve the electric potential energy is equal to that, because to find the size of the nucleus in that case. We have one small example over there. So the charge on a tiny nucleus is plus 50 electrons. How close can an alpha particle with an initial kinetic energy of 1.6 pj approach the nucleus of the tiny atom? Assume the alpha particle really far away initially. So we have alpha particle and we have a 10. That R you have to find. That the how far they do, so R you have to find. Initially there is a far away. So initially your V is equal to 0, V takes is 0, and there is a far away. If there is a far away, so your EP is equal to 0 in that case too. So you get EP is equal to 0, or for this you can involve something like the EK, something like just translation of energy law you have to find. So EKA plus EPA is equal to EKB plus EPB. Initially, so EPB. So initially your EPA goes to 0 because the far away is mentioned, and after that your EPB EKB is also goes to 0. That is. So from here you get EKA, which is equal to EPB, and this is 1.6 PJ is given to you is equal to the EPB. This correctly says that this is your answer for that, and you get EPB. So EPB is equal to K. So first the charge you have for alpha, then you have for 10 divided by the R. So for R you get the answer. So 8.99 to 10 raised to power 9 Newton meter square, Coulomb square. Alpha particle charges you that from the formula sheet, 3.2 in 10 raised to power minus 19 coulombs. And for the Sn you get the 50 leptons, and the lepton elementary charge has a value of 1.6 into 10 raised to minus 19 coulombs, like this, and this whole divided by the 1.6, and P, which is P has the value of 10 raised to minus 12 joules. When you calculate this, you get your R of about 1.4 in 10 raised to minus 14 meters. You can't get questions from that topic, questions from that formula, but you have to know this formula, because no one knows you get the question from here. But this is not very important topic. You have to more focus on the theory part of the Rutherford model and the discovery of the nucleus. So that's the discovery of the nucleus and the Rutherford model, and that we have to know in this, and this is a very important thing from there. And now in they said that leptons are orbit the nucleus. They said that. Now in the Bohr model of the atom, they will do some more like things in that thing, the orbit thing, and we involve some spectrum thing too. We do basically the atomic spectra. We have to know some spectrums in that, and the next lesson we discuss that. So for this is all for this lesson. So remember to EduVibe, learn smart, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till let's get it with EduVibe.